Good evening, everyone present over here. We welcome you all to this session on thinking in DevOps. My name is Ishita Jaswal, your host for today's session, core team member at Developer Students Club KIET. We are a community of developers who loves to learn, share, and code together. Our motive is to create an ecosystem of programmers and developers on the campus by helping them to learn and build projects. So, have you all ever wondered how organizations like Google, Amazon, and Netflix are able to deliver their best services at such a rapid pace? If no, you are at the right place and with the right person, Mr. Shlok Srivastava. He has been working with databases and infrastructure at Razorpay. He worked with Clarisights to help scale their infrastructure to handle the analytical workloads at scale. He is a maintainer for an open source software that is used to host conferences like LinusConf, RubyConf, etc. He has also worked with developers who help to develop the Ruby programming language to help better track security vulnerabilities in the Ruby ecosystem. Hello Shlok, we welcome you to this session with DSC KIET. I hope that you are doing good. So
Hey Ishita, yeah, I'm good. How are you?
I'm also fine. So how's your professional life going in this COVID time?
It's going good. We're making best of the situation we currently have. And anyway, professional life in this COVID times is not that easy as it seems. There's a very thin margin between having a professional life and your personal life kind of intermingles when you're doing work from home. But yeah, it's going good. Yeah.
Yeah, that's great. So, without any further delay, I guess we should start the session now. So, before moving, I would like to inform you guys that if you come up with any queries during the session, you can post them on Slido. So, what you have to do is simply go to slido.com and enter the code DSC KIET. The link has also been provided in the message window. We can take those questions at the end of the session. Okay, now over to you, Shlok. Thanks.
Okay, thank you, Ishita. I'll go ahead and share my screen.
Yeah,
Are you guys able to view that? Is it visible?
yeah, it's visible.
Okay. Okay. So before we begin, thank you, Ishita, for such a great introduction. Yeah. So before we begin, I'll have a few reality checks in mind. So I'll I'll let it be for a minute on the screen so that you can read through it. Let it sink through. This is what today is going to be all about. Yeah. To basically sum it up, what I've tried to explain here is key. Today I'm going to focus on what DevOps is and why we actually go about doing the practice of DevOps in various organizations, rather than reading about how we do it, which is something that you can obviously find online if you go ahead and search for it. But giving you a direction to look for is probably better than just making you learn stuff, right? So, so I'll try to focus on that direction. And people who have any contradictions, please feel free to speak up. Just unmute yourself. The reason we are doing this on Meet is so that you can unmute and you can speak. Okay, this is just any contradiction, just speak up. Okay, I'll be happy to. You can have a good conversation. You can have a good discussion. We will come to a conclusion. Maybe I'm wrong at some point. So just just interact. Okay, let's make it a conversation. Let's not make it a YouTube session that you're watching, which is probably boring anyway. Okay, so yeah. And fourth, the most important point is these are my personal opinions, although these are gathered by a lot of resources and my experience as well. Uh, but again, DevOps as a term is slightly, I won't say misinterpreted, but it's interpreted differently from organization to organization. So my personal opinion might not match everyone's personal opinion here. So you have to use a better judgment. I'll give you my opinion. I'll say that things we do it this way. If you think that's not the right way, go ahead, look for it, Google it, find the better way to do it. That would be very nice actually. Okay. Do you have any questions? Anyone? Just
I think we can start now. We can take those
okay,
questions
sure.
and then.
Okay, awesome. Cool. Let's begin. Let's begin with the classic question about how any presentation is going to begin with. What is DevOps all about? What's the topic is all about? Anyone wants to explain it in their own words? Anyone here want to say what DevOps is all about? Just anything. Just make a guess. Come on, guys. You must have done your homework before joining this session. So yeah, just unmute yourself for something. So Mayank, Ishita, do you have any idea what DevOps is all about? What this buzzword is all about?
Developer operations.
Yeah, Anubhav. Yes, Anubhav. It's developer operations. Good. Anyone else?
Set of
Okay.
practices.
Uh, nice. Yes, that's one way. Anyone else? So as Anubhav and Sahil mentioned, whenever you look up the word DevOps or developer operations, you're gonna find two diagrams there. One is this loop that I have mentioned above, and one is this pie chart. So what it actually sums up what DevOps is, right? So I'll go a bit before in time, and I'll say what used to happen in different organizations is we used to have different silos, right? So developers are working in in their own silo in their own environment, and then there was this developer team and there was this IT infrastructure team, right? So IT operations, IT infrastructure team. So they used to work quite separately, right? So developers team were responsible to bring in new features. They were responsible to bring in new features, add bug fixes and stuff like that. And the IT operations team used to handle servers or manage infrastructure and things like that. Now here there was, as you can see, this is highly correlated, right? You cannot bring a new feature unless you have an infrastructure in place, right? Which makes sense. And same goes for bug fixes. Anything goes wrong in the infrastructure is going to affect the development pipeline as well. So these two things cannot happen in different silos. These two things have to be connected, right? But people lack different skills to actually go ahead and connect these two to actually establish a communication or collaboration between the developer and the operations team. So this is why DevOps came into picture. So if you look at the if you look at the term, now the term came into picture in 2009 around it was quoted, but knowingly or unknowingly, I think it has been happening since long before that. People have been using practices to help this better communication between developer and operations team. Okay, so so this is about the term DevOps, okay? But essentially what DevOps is, as Sahil mentioned, it's a set of practices. Yes, essentially DevOps is a set of practices, but that's not what it's all about. As I mentioned, this is the backbone of DevOps, like connecting developers and operations team together. Yes, you can follow a set of practices to achieve that. It's but that's not enough actually. So essentially people relate DevOps to using things like Docker and Kubernetes, but can you so DevOps is not just about tools per se. DevOps is a philosophy. That's what, if you actually search for the term, you'll come to know about DevOps is actually a philosophy. DevOps is actually a culture. DevOps is a culture in which every developer has to be aware of operations as well. It's a culture that is followed by a tech team. It's a culture in an organization. It's a culture shift for developers to be aware of operations, and operations to be aware of developments, and vice versa. So that's what DevOps is all about. Right? It's not just about you go ahead and automate a process, right? You can go ahead and automate anything, right? But then continuously looking back at the faults of that automation and fixing it, then going ahead and iterating through this, that's what DevOps plus development plus operation is all about. So I hope I have given you some idea about what DevOps is. Even though I couldn't, here's a complicated slide. Here's a definition, not by me, but different organizations. You might want to read through it. I'll give the slides to the end. I'll give the slides in the end. The reason I have just four of them is because they elaborated quite well about what DevOps is. So that's it. So it's not just tech skills about having set of practices, but it's also about soft skills about implementing the correct practices as well. So that's what I think what DevOps is. Right. Okay. So here's a separate slide. it says automate. The reason I was satisfied for automation is to just emphasize on this word. If automation is actually the heart of DevOps, it's what DevOps is at the end all about making processes easier, automating the processes. Okay, and you have to keep in mind, you don't want to be a human cron job. Matlab, you don't want to do the same thing again and again every day. That's killing your time. That's killing your effort. That's costing the organization a lot of money. It's useless, right? So that's when DevOps comes in and you automate those processes. And the processes that can be automated through code, through scripts, or through any pipelines, DevOps does that job. This automation is an integral part of DevOps. Yeah. Okay. Any questions? It's a reference to Mirzapur if someone gets it. Any questions, anyone? And guys, it would be nice if we turn on our videos because otherwise it feels like I'm talking to my presentation. Okay.
You
If
put
no
the very
questions,
same
I'm
mood
gonna proceed.
in the photo.
Yeah. Who was it? Sorry.
I'm saying that you put the same mood in the photos about the questions.
Exactly. I knew the first time nobody's gonna ask anything, so I was like, okay, Munna bhaiya. Okay. Okay, shall I move ahead then? Okay.
Yes, sir.
Yeah. Anyone?
I think we can move ahead.
Okay. Okay, Shita, we move ahead. Uh, I'll talk. So talking about trends in DevOps, go ahead, Google about it, man. You'll realize how it has been increasing continuously back since DevOps was quoted. So since 2007, 2009, the trends in DevOps have been increasing. Uh, on the top left is a survey that was conducted by Google. So it was a survey that was conducted in the end of 2019, and it just shows how DevOps has been going from organization to organization. Since this problem was first recognized, the gap between developer and the operations team, and the people who have successfully accomplished developer plus operations, they're actually moving at a much faster pace now. Much faster pace, whether it's application development, whether it's feature fixes, whether it's anything. They are moving. Their tech teams are going at a much faster pace. That's why DevOps is continuously being incorporated more and more across organizations everywhere. Okay, a quick poll question. Have you guys heard of this term, move fast and break things? Have you guys heard of it? So
Yes, I
can
have.
someone give me who?
Yeah, yes.
Are Atman, hi. So can you
Yes,
give
sir.
me who
Yeah,
quoted this term?
yeah. So if you like try to like move fast, we generally end up breaking things.
As Atman, you have worked in the software industry, right? So
Yeah.
tell me this. Do you think it's a good practice to move fast and break things?
No, it is not.
Yeah, exactly. Uh, so the answer to this question is key. This was quoted by Mark Zuckerberg back when he was building Facebook. And so he quoted this, and he actually said this is the Facebook's motto, right? To move fast and break things, to move at such a faster pace, just break things and fix them. But it's essentially not you should do. So everyone is entitled to their personal opinion, but if you do go ahead and move fast and you break things, uh, you need to have systems in place in order to fix those things at a continuous pace as well. So if you move fast, you break something, it's going to be broken for the next couple of hours. It's going to directly impact your customers. It's not a very good place to be in. So this might be a good idea, but this isn't a good idea when you're working at a larger scale. Apparently, Mark Zuckerberg, he retracted that motto in 2014. It was changed to move fast with stable infrastructure. That's what ideally it should have been. So yeah. Okay. Okay. So I talked about DevOps. I talked about what DevOps actually is. I talked about that DevOps is a culture per se, right? DevOps is not tech skills. It's not just a set of practices. Not using just a set of tools like Docker, Kubernetes, or anything as such. It's a culture shift. Now this brings up the question: then why are DevOps engineers engineers? Isn't it? right? If it's such a culture shift where we're not in the operations team per se to bring the better communication between IT infrastructure and um, IT infrastructure and the developers team, right? Does it bring the question to anyone's mind? Yes, just write in the chat. Yes, at least I'll have some feedback. Uh, okay. Okay. So it's a meme out there. Obviously, AWS certification means something. So don't think that it means nothing. It does. So, okay, here's the reason why DevOps engineers are actually engineers. Although DevOps is a culture, as I said, DevOps engineers are the person who enables that culture in a particular organization. DevOps are the people who actually evangelize the use of correct tools, of correct practices, to actually enable the DevOps culture in a particular organization, right? That being said, it's not the complete responsibility of a DevOps engineer. As I mentioned, DevOps is slightly differently interpreted from organization to organization. Uh, DevOps, so essentially what we have come to in some of the organizations, we have a developers team and then we have a DevOps team. Not the DevOps team is responsible for not just the DevOps part, but also the operations part. So we have a developers team and we have a DevOps team that's working to bridge the gap between the developers and operation and also perform operations, right? So ideally we are in a scenario where DevOps team also takes care of infrastructure. DevOps team take care of identifying bottlenecks. It takes care of tuning performance to your servers, take care of um, tuning your databases. So essentially, if you have an application, right, it's serving traffic to different customers, say Swiggy or Zomato, right, and you're scaling rapidly. So Swiggy had a very rapid growth. Swiggy had a very rapid growth, and like in a couple of years, they increase 10 folds, 20, 50 folds their customers every quarter. So that is so predicting the rapid growth of Swiggy with the current KPIs and how will our current infrastructure be able to handle uh, these changes when it comes in, these many requests when it comes in. That's that's also part of DevOps. Now, as your as your infrastructure increase, as your customers increase, so will your developers increase, right? So earlier you have like 10 developers working in your organization, right? Writing code, 10 developers writing Ruby Python code. Then suddenly you have bunch of workload. You have 50,000 more requests every day. So you increase your developer capacity. You want to build faster. You make new features. You want to make new features. So increase the number of developers, right? Now from 10, they are say 150, 200, 300, 400. Now, as the developers increase, the pipelines you had in place, the automation you had in place, it's going to affect them too, right? You cannot run that job sequentially anymore. You cannot run that job that was written for two developers sequentially, right? You need some sort of parallelism. So you have to scale your internal tools, internal DevOps tools and deployment. So DevOps is the person who maintains your internal tools, whether it's infrastructure, application planning, CI/CD pipelines. DevOps is the guy who does that. Uh, okay, and DevOps is also the person who takes care of on-call rotations, incident response, incident management. If I'm not sure if people are familiar with the notation on-call here. Uh, okay, we'll cover it probably later. So DevOps is also the person who take care of monitoring your infrastructure resources as such. So yeah, okay. Okay, so DevOps is a culture, right? It's a culture shift, is a paradigm. So how it's a philosophy per se. So how can I skill myself in it? Right, there's the first question, how can I get started? So even though DevOps is a mindset, tools are still important. Tools are a way to achieve that mindset. Tools are a way to achieve that continuous integration and continuous deployment cycle. So we cannot do DevOps without having those set of tools, without having an understanding of those set of tools. Yeah, so tools are important, but they are not everything, right? There are thousands of tools out there, but you don't learn a tool. You learn the problem that tool is trying to solve. Don't be the guy who has, say, Ansible in his resume and who doesn't know what configuration management is, right? Don't be the guy who has Jenkins in his resume but doesn't know what continuous integration and all that is. So you don't have to be the person. You don't have to be the person who has Kubernetes but doesn't know what container orchestration is and what are the alternatives to that. You don't need to be that person, right? You have to understand the problems. Everyone can learn just these, but understand these problems. So yeah, just remember this rule: tools are not rules. It had a rhyme to it, so I did the music bars, but yeah, that's essentially to make you memorize this. Don't stick to a particular tool. Don't be clingy as this frog is. Okay, just analyze the problem and use your brain. That's what DevOps is all about. Okay, that being said, let's start with one of the practices. Okay, let's start with processes. So I don't think we want to start with tools, as I mentioned, but we can definitely start with processes, of which is the first process. Brings me to first process, which is containerization. Anyone has any questions until now? Please feel free to ask. Any questions, anyone? Okay. Can anyone give me example of containerization? Any tool that can do that?
Docker.
Docker.
Okay. And okay, so whenever you say containerization, this is the reaction of almost everyone you meet. I know Docker, right? It has become the standard. But the point is that's not it. But yeah, it is for every practical purposes we end up using Docker. Right? People have forgone the term containerization, but and they have took the term Docker into consideration now. So yeah, this was Jan above. Okay. Yeah. Uh, okay. So it's I don't want to get into depth, but this is somehow how Docker works. We need this basic understanding so that we can move into continuous integration. Uh, yes, Atman, it's like Colgate for toothpaste. Yeah. So we need this basic understanding before we move into continuous integration. So how Docker works is we have different containers running parallelly on a host machine. There's this Docker daemon running, which has REST APIs and a Docker CLI to interact with, and then we have multiple containers running on the host machine. Now, what actually one container is? A container is. Can anyone explain what a container is? Atman, you wanna take a chance?
I afraid I won't because I have never worked with container that much actually. I
Okay.
just use
Anyone wants to?
containers for my work purpose, but never,
Mhm.
get inside it.
Yeah. Okay. Anyone wants to
Uh,
explain what container is?
Somewhat like virtual machine, not exactly virtual machine. I mean, containers
Mhm.
have enough configurations and setups to run some commands without any. I'm not sure what I'm saying, but I hope you get it.
Yeah, Ari, you're saying it perfectly, man. Yeah.
Yeah, I mean, they are not exactly the virtual machine, but they function like virtual machines with
Mm,
very less space and setup requirements.
mm.
Yeah.
Okay, yeah, that's exactly it. Confident row. That's exactly it. So Docker is somewhat like a virtual machine, but it's not a virtual machine. The way it's not a virtual machine is it doesn't have an hypervisor to share the system resources as such. It instead has a Docker daemon running. So the Docker engine, as they say, consists of a Docker daemon, some REST APIs, and all that. So that it essentially has Docker daemon running, and containers are very cheap to start. They bundle everything. So to run a particular software, what do you need? You need an operating system, right? You need dependencies. You need to install the language the software is written on, to install the compiler for that language and all that. You need to yeah, exactly. So you need some resources to run the container on. With Docker, you can get all these in one particular image, right? So you have one image, and you can share that image across anyone, and essentially that a particular image will bundle all the dependencies together, right? It has the host operating system in which everything is going to run perfectly. So that's in a very non not using any technical jargons. That's what containerization. That's what Docker is, right? Now let's see how Docker works. Okay, everyone excited? You want to see how Docker works?
Just a question. So, what is the difference between a virtual machine and this thing? Like, how will it perform?
Okay, so virtual machines have something called as a hypervisor or VMM that is used to share the resources of a host machine. So you have a host machine, and then you have guest machines. So you have a host OS, and then you have guest OS on top of that host OS. That's what virtual machine does. In Docker, you don't have a concept of having guest OS. You don't have a hypervisor to take care of sharing resources as such. You have a Docker daemon running that takes care of all that. So virtual machine essentially so this hypervisor process essentially takes a lot of time. So to share the resources of a host OS so that guest OS uh, are able to use those particular resources that they are allotted, um, it's it's a time taking process, right? It takes a couple of minutes for one guest OS to come up, but it takes hardly a few seconds for one container to come up, right? So that's essentially a difference. If you're familiar with AWS, you go ahead and create an EC2 instance, right? You go ahead to GCP and create an instance. There, you're creating a virtual machine. So they have in their servers in the cloud, in their data center somewhere, a machine with the hypervisor, and then you're creating a guest OS on top of that hypervisor. That's what virtual machine is. And if you run a Docker container on top of it, that a guest OS, that's what containerization is. So essentially, if you are running a Docker container on AWS, that's a combination of having a virtual machine plus running containers.
Okay, thank you.
Okay. Anything else? Any
Can you please
questions?
explain a little bit on image? What do we mean by
Uh,
exactly image?
so an image is like a name, Atman. So if you have a Docker image, so you have something to. So if you have Docker image ID, you have something to associate that name with. Essentially, it's a set of commands, right? It's a set of commands that is gonna tell Docker ki when you're running a container, this you're gonna run using these commands, right? It will tell you. So an image will contain your operating system. It will contain the name of the operating system your Docker has. It will uh, it will contain all the dependencies. So you're gonna do a from command and then specify the operating system. Then you'll run to install some pip dependencies. Then to install some Python and start your Unicorn server or whatever that is. So essentially, it's a set of commands, and there's an image name to identify that particular image. And you can go ahead and push that image to any registry as such,
All right.
and then you
That's
can fetch from it. Yeah, cool, man. Okay, so we're not gonna go in deep about how Docker works. I'm sorry, I was just kidding. This is not what the talk is about, but essentially we went a little deep in the last 5 minutes. But the talk is about how, and this topic is not about how we use different tools, but about what and why we use them, right? So let's see why we use containerization, why we need containerization rather than how Docker works. You can just Google it. You'll find how Docker works. There are tons of videos on it. Okay, so why do we need containerizations? As I mentioned, container is a very cheap resource to start. Cheap, I mean not in terms of money, but in terms of resources, right? So running a container is not going to cost you much resource. It's not going to cost you much CPU or IO or anything like that. So containers are very cheap to start. Okay, it's shareable. You can create an image, and ideally, I mean portability. You can create an image and then you can share it across your organization, share it across people, and they can just get that image and run it. Nobody has to care about dependencies as such. So the Wrangle dependencies part come into shareability as well. So you have to install it. Essentially, one container will have all the dependencies. It will run the service. You have to do nothing. Just clone the container, run it in your local, and you'll be able to access the software you want. So that's so essentially, if we end up using Docker in an organization, what it's going to help us, how it's going to help us. Suppose you have 10 developers. One is working with Mac OS, others have Linux or any other system. If they work with a Docker image, if your code is deployed in a Docker image, it's going to be platform agnostic, right? It doesn't care about the host system. It doesn't care if it's running on a Mac OS, on Ubuntu or Windows or whatever that is, right? So that's going to help in productivity, developer productivity a lot. You don't have to set up the same database you don't have to go ahead and set up Postgres on every different operating system. You just create a Docker container out of it and share it across your organization. That's how Docker can help with DevOps, right? Essentially, let's not forget our aim. Our aim is DevOps, right? Making developer operations easier. And that's why I'm listing down reasons how we can do it through Docker, not what Docker is. Okay, Docker can die and respawn anytime. That's one of the uh, good points about Docker as well. Let's move ahead. Any doubts on it? Anyone? So this was about containerization. Um, let's move back a slide. Yeah. So this is actually different. Could this most of them are alternatives to Docker per se, which most of the people might have not heard about because because for almost every practical purposes we end up using Docker. But if you look at Rocket, if you look at Podman, you get Apache Mesos, OpenShift. Rocket claims to be more stable, more secure than Docker. So you go ahead and look at them, look at the differences between them. It's something you should know about, not just Docker. This slide is just to, so you have a container, right? You have a mechanism. Now you need a mechanism to run multiple containers at once, right? To run, you need some sort of orchestration. By orchestration, I mean you're running 3 different containers. You want to load balance between 3 different containers, request coming on 3 different containers. That's when container orchestration is required. I'm not gonna go deep into it. Let's just, this is just here to focus on the buzzword Kubernetes that has been going on since the past few years. So Kubernetes is nothing but an orchestration tool to help you manage those containers. Okay, here comes another part. Right. So essentially, this will cover 3 parts: containerization, continuous integration, continuous deployment, and monitoring. This is what I want to cover today from DevOps toolkit point of view, right? Okay. So the reason I put containerization first is because you somehow need containerization before you go into continuous integration and continuous delivery. Okay. So this is a superset of all DevOps practices, you can say. Uh, yeah. So here's a broader definition of continuous integration, and CI and CD, which is pretty boring to read. That yeah. So I'll try to explain in simple words. Can anybody do that? Can anybody explain what CI/CD is? Anyone, please go ahead. Let's take a guess. Continuous delivery. What is so obvious about this term? Continuous delivery. Come on, just take a guess. What could be obvious about it? It just says right there, continuous delivery.
So CD is about whenever any code changes are there in the repository, then it is directly pushed into production without the
Okay.
need of manual efforts.
Okay. Okay. Nice. Good. Yeah, that's essentially what it is. Nice. Yes. Sorry, Aman, we could not hear you. You were saying something. Okay, we cannot hear Aman. So yeah, Rajat said it right. So that's what continuous delivery is. Before we can introduce continuous delivery, we need to know about continuous integration as well. So continuous integration is just what we do with GitHub most of our time. We have a single uh, tree. We have a tree of our code, right? And multiple people come in and push their code. We have a one copy of code that can be deployed at production anytime. And so some guy came up and pushes his code. You're going to run automated test suite and see, yeah, everything is fine with your particular code. That's what continuous integration is. If it's not, the reason it's continuous integration, not just integration, because if it's not, if your test fails, you go back, you're informed that developer, hey, something wrong with this code and this test is failing. It's going to fix it and it's going to integrate in that repository again. So your source code is essentially full of bugs. It will definitely have bugs, but full of most of the bugs that can be introduced by one of the test systems that can be filtered by a test system. It won't have those bugs. So that's what continuous integration is, right? Having a source repository, source code, it's full of multiple developers working on it, but it's still continuous integrated. It's deployable, right? Now this part is still having a source code and then going ahead and deploying this in production is what continuous delivery is. So you go ahead and deploy your source code in production. If there's an issue, you can roll back to a previous version. You just do it faster and faster. That's what continuous delivery is all about, right? That's why it's so obvious with the terms continuous and delivery. What else can it be? Okay. Yeah, a couple of boring concepts of why we need CI/CD. Deliver software more rapidly, which is fairly very obvious. This is like the sole reason, and everything encapsulates in this particular heading. Everything else in the on the sheet. It's like more like an UPTO answer with 1 point elaborated on 4 points. But yeah, so you can deliver software faster and more rapidly if you have CI/CD. You don't have to wait for any of the developers to finish their work before your work is merged. So if two developers can work parallelly on separate features forked from the same repository, that's how GitHub works. Please go ahead and look at it. So you can find and address bugs quicker because of your test suite will run only on that particular code that you have changed. You can configure it to run that way. You can go ahead and actually um, find your bugs fairly quicker than you could before. Like running the test suite on your local is it's a pain. It's a pain. Okay. Introduce which internal improve developer productivity. Okay. So essentially the same point. Just a random question. What do you think is the mean time to deploy applications for Amazon? Just take a guess. Any number. Anyone, come on. Just take a guess. 3 milliseconds. Hi, Tanay.
Before a sale,
Yeah. Anubhav, yeah, I didn't get that.
right before any kind of sale, because that time minimum number of users will be there on the platform.
Yeah. Yeah. So essentially, what I'm trying to ask is, what is the mean time to deploy applications for Amazon? At any particular point of time, right? Like if you see this year from starting to beginning, what was the mean time between two different deploys? Just a random thing. Just take a guess, right? 15 seconds. It's actually very close. Okay. So okay. Anyone wants to take another guess? 10 seconds. Cool. Okay, that's uh pretty close. So so Tanay said 10 milliseconds. Tanay, I'm not sure if it has changed or not, but I'm a little outdated, I think. What I read, it was, I think the numbers were back in 2016. The average time was 11 seconds. Hey Tanay. Yeah. So number as the mean time to deploy applications for Amazon was 11 seconds. Which is pretty amazing. So this has been only possible after the introduction of AWS and after they have started using these applications. Imagine you're using Amazon. Yeah, you are sitting on a page for 11 seconds. They have triggered a deploy and they have rolled out something new. You didn't even know about it, right? So it's that fast now. Yeah, 7.7 seconds to be exact. Okay, different CI/CD tools out here. So Jenkins is like the industry standard now. I don't know if, most people end up using Jenkins. Essentially, if you go into a DevOps interview, you please expect some questions about Jenkins. Even though you don't know about Jenkins, I remember sitting in an interview with Oracle, knowing nothing about Jenkins, not being Jenkins in my resume. Even then also they asked me questions about Jenkins, saying you should know about it. So it is becoming industry standard. Some people doesn't even care if you know about CI/CD. You should know about Jenkins. So yeah, it is an industry standard. Jenkins says GitLab does that as well. Travis CI, which is pretty easy to get started with. We have like this Pokeball is drone CI. Then we have Spinnaker. Spinnaker is a tool by Netflix, which is pretty neat. It's fairly new, and it's a lot powerful. So Jenkins and Spinnaker is something that you should go ahead with. If anyone want to go hands-on with these things, please do that. Create a GitHub repository, and I'll give you a link to integrate Travis CI to it. You can actually go ahead and use continuous integration and continuous deployment through that repository. It can be a nice project to do. Okay. Okay, let's quickly jump into configuration management before we go into monitoring. Okay. So what configuration management is? Can anyone take a guess in the audience? Anyone wants to? Anyone wants to know what anything about configuration management? Just
It's
give me a
like
guess.
administering multiple systems. You can say that, or
Yeah, in a
managing
way,
multiple
yes,
systems,
yes.
the
In
dependencies
a
and
way,
all
yes.
that.
It's yeah, exactly. Fine. So it's managing multiple system their dependencies, but so syncing their configurations to a tool or any set of practices. right? To explain it a bit more, let's take a simple example, right? I hope it's clear, right? It's readable. Yeah, so we have a simple e-commerce website. We have an account service, an inventory service, and a shipping service. So shipping service takes care of shipping your goods across all over the country. Inventory service takes care of what's in the inventory, and there's an account service, right? To for a particular account, whatever it is, we have just three services, three different databases, two client-side application. One is a mobile app, one is a web app, right? Now consider a situation where you have to go ahead and upgrade your database, right? Previously it was older version. You have to upgrade it. You have three databases here. How are you gonna go about doing the upgrade, right? So one process could be going ahead and doing it manually. Going ahead first updating the account DB, then the inventory DB, then the shipping DB. So that might be the first approach to go ahead and do it, right? But it's time taking. And what if you don't have three databases? What if you have like 10 databases? What if you have 15 of them? What if it's not a database, it's another service, right? And you have 25 copies running of that service, 25 different replica sets, and it's sharded cluster and all that. So it's gonna get complicated, right? You cannot just go ahead and do it for every database or every server. Go ahead and manually trigger it. Manually do it. It's gonna take a month for you to do that. That's where configuration management comes and helps you out, right? Okay, okay, I probably answered that, so it's fine. So what it essentially does is so you okay. So with you don't guess what the configuration of a version currently is. You have a state of it around. Okay, so you have a state of your database version, and you have all the configuration of every database in one place, sort of, right? So you have a management system, you have a configuration. You're gonna get and click a button, it's gonna get applied across all the clusters. That's why I said automation is the heart of DevOps. Everything that we have covered till now helps with automation if you focus on it, right? So this is how it's gonna help. Now here there are obvious workarounds. This process requires human discipline. What I have noticed across a couple of organizations that are initially starting up is they lose that discipline. Instead of configuration management, what happens is if you go ahead and manually update configuration of one of the databases, it's gonna mess up the state, right? So you need to have human discipline, and that's what DevOps is all about. It's not about you just using the tool; it's about using it right. Okay, so it's not just about technical skills. You need to be process oriented. Yeah. Okay. So that's it. That's what configuration management is. So you can have better release cycles. You have a status, right? You can so you have greater reliability of the system. You know about the configuration. It's in one single place. You can go ahead and update. It's better agile. It's faster. You can resolve problems faster if there's any bug in your if you think that there's a vulnerable software that has been currently deployed and you need to bump up the version instantly, you can just do it with a click of a button and you can resolve that problem very fast. Any security issue, you can do it faster, right? So a bunch of tools I can help you with it. So Ansible is mostly an industry standard. So we have Ansible, we have Puppet, we have Chef, we have TeamCity, we have SolarWinds, we have SaltStack. SaltStack is also something that is extensively used. We have Terraform. Terraform is essentially provisioning, but yeah, it can come under configuration management as well. So we have Terraform here as well. So again, a lot of ecosystem around tools of configuration management. But before we dive into any of them, we should know about what configuration management is and what could be the right tool for a particular situation, right? Okay, this is probably the last thing I want to cover today. It's monitoring and alerting is one of the most important thing when it comes to maintaining a DevOps ecosystem. So everything we covered till now, what it will help with is having that automated DevOps ecosystem in place for any organization to be faster in their development cycles, right? Wouldn't it? That's the reason why we have so many things in place, right? To get skilled at DevOps, if you came and joined this talk to have some shortcut on how to get skilled and get a job as DevOps engineer, essentially the tools that I've mentioned and the reason why we use them, it's going to be very important. It's going to build up the basics for it. So let's just start with monitoring and alerting. Okay. So anyone, any hints on what this could be about? Says right there, it's about monitoring systems. And as your scale increases, you have multiple systems, you have multiple databases in place. You need to have some sort of tool to actually go ahead and monitor them and alert someone when something wrong happens, right? Let's take the same example, same service, same databases. Suppose at night one of your database gets throttled, right? There is too many questions. There's too many connections to the database. It could be any reason. Let's just say it gets throttled, right? You don't know about it. You just know ki when someone goes to Amazon, opens the page, and it takes a lot of time. Okay, it is taking a lot of time. You don't know what the time is, where the time is going. You just don't know anything about your system. That's the worst mistake people do when they actually go ahead and start an e-commerce business. Most of the e-commerce business, they don't have that much of technical depth, and they end up leaving, and then end up figuring it out later. Uh, Point after they reach a particular scale, then they realize there are problems, and they go about and start implementing their tools. But if we do it from the beginning, it's going to make the process very, very fast. Okay, it's going to remove that bottleneck period of time of a startup when it's growing and it's going into tech debt most of the time. Okay, so suppose it gets throttled, right? One of your database gets throttled, you don't know anything about it. How do you know? How do you go ahead and debug the system? Right? You go ahead and look at your server, you go ahead and look at its logs, you see key of um, what's taking so much of time. Is it university service? Is it the account service? You go ahead and identify, okay, this is the account service. Now, now what next? Why is account service so slow? It's a database now. So you go ahead and identify that. It's just a time taking process, right? Instead, this could have been simplified a lot if you had monitoring on a database. If you had just one metric, just export the number of connections that are currently being made to database, you would know that they have increased and database getting throttled, and you could have done it in like 15 minutes, but you took like a complete week to fix that. That's what DevOps is all about, doing these things faster, right? Uh, so we monitor? Why are we monitoring our systems? You can see there in the slide, I have some points here why we go ahead and monitor our systems. So the first is fairly what I mentioned before. It's to reduce MTTR. What MTTR is, okay, I'm sorry. I tried to reduce the number of jargons that I have in this presentation, but somehow this ended up here. MTTR and MTTD is mean time to resolve and mean time to detect issues. Um, so you go ahead and read about them. So it uses the mean time to go ahead and detect an issue before it happens if you have alerting in place. And mean time to resolve is to resolve those issues, right? So the time taken to resolve this particular issue, it's going to reduce it if you have monitoring in place. It's going to help with that as well. And you can identify problems before they actually happen, right? So you have your CPU. So let's take a basic example: CPU increasing for a particular database, right? You can identify it. You can see the pattern. You can see, hey, this TB is under heavy load. Let's bring it down, right? Let's just start the replica. Let's just send some guy to the replica, and it's all gonna be fine. You can proactively detect these problems if you have monitoring in place. But if you don't have monitoring in place, you're gonna end up with a downtime. Your customers getting affected, and then fixing it later on. So it's essentially move fast and break things, but that's not what you want to do here. Okay. It reduces manual efforts, as mentioned before. It's kind of the same thing. You can derive insights which are done can help with cost analysis. Yeah, this is also one of the most important thing is key. You can derive insights from monitoring. Like if you have a server running on 8 core machine, running if to give you about idea about cloud computing, CPU is very expensive there. So we have to be careful about how much CPU we allot to any particular server or anything as such. So if you give very access CPU to a particular server, it's going to cost us a lot without any reason. So if you see, hey, CPU utilization is like 10%, you can reduce it to we can reduce the number of CPU allocated. You can do that if you have particular monitoring in place, right? It's going to improve your KPIs. KPIs are key performance indicators. Some give you some example of KPIs. You can have MTTR, MTTD. You can have your platform uptime as one of the KPIs, and you can have incidents, number of incidents that happen. You can have failure rate as one of the KPIs. So you can have, as I mentioned before, mean time to deploy as one of the KPIs. You can have deployment time efficiency, how much time does it take to trigger a deploy until it's actually rolled out in production as a KPI. But these KPIs, you can identify them with monitoring and then work on improving them, right? Even if you don't have monitoring in place, you wouldn't even be able to identify these KPIs. Do that make sense, right? Yeah. So that's why we have to monitor our systems. Anybody has any other points related to this? Anything? Yeah. Okay. Just what should you monitor, right? If it's a very open-ended question. There's no straight answer to it. Um, so let's speak our mind here. What do we think that we should monitor?
CPU usage,
Okay, that's one thing.
database connections,
Okay, good. What else? What else?
Services, applications, anything, or any systems that are
Okay. API
API
request,
hits,
Time.
response time. Yes. Yes, Shashank. Right. Right. These are all correct answers, man. Yes. So if you have to broadly classify it, of any user-facing application, these are like the four pillars to monitor. This is not me saying it. People have different opinions. People monitor a lot of different things, but these four pillars are from the SRE book of Google, which is like some of the DevOps principles followed by Google and how Google evangelizes them. It's all in there. So it's one of the things that you should probably refer to. That's what I refer to, and that's where these four pillars come from. So for any user-facing system, what to monitor is traffic, latency, saturation, and errors. Okay, errors are anything, any 500s or any sort of error in your application, right? That are essentially errors. So how many of your requests failed, uh, and all that. That's going to be your errors. Now this is for user-facing application. For database, you can have page faults and things like that. Then you have saturation. Saturation is can anybody guess what saturation is? Come on, take a guess what saturation could be. Sahil? Okay, I said Sahil because Sahil, you mentioned CPU usage. It would come under saturation. So saturation would be the limited resources you have and how well are you using them. What are the current saturation rate, right? The CPU percentage, CPU usage is going to be a percentage, right? You can go up to 100%. So you have these many cores available, you can use these many CPU. So it's kind of saturation, right? Memory usage, how much memory are you using, and how much is total allocated to the system. Disk IO, how much disk IOPS are you using, um, complete utilization of CPU. Yeah, but we don't want complete utilization of CPU. That's why we should monitor saturation so that it doesn't get saturated in the end. Okay, so yeah, and your disk usage percentage, all that would come under saturation. Okay, um, next is traffic. As Rohan probably mentioned in the chat, traffic is the total number of requests you are receiving. When it's database, number of queries is receiving, total number of rows is touching per query, and things like that. It's going to be traffic, and latency is obviously um, the response time. As someone mentioned in the chat, latency is the response time for a particular application. So these are essentially the four pillars. And this can be classified, divided broadly into different metrics. But ideally, if you monitor these might be sufficient for application to begin with. Okay. So as what I did with all other processes, listed out tools in the end. This is what I did with monitoring as well. Although this is just a drop in the ocean, guys. Um, Monitoring tools are vast and vast, which is true for CI/CD tools as well. Something I mentioned before. It's a very vast ocean of a lot of tools and different companies available, and it's keep on increasing. Many companies are coming up right now, so it's a problem that is still being solved by a lot of people. Okay, some of the most common monitoring tools I've mentioned here. We have Nagios, we have Elasticsearch, Datadog, Grafana as a visualization that can use any type of data sources like Prometheus or Graphite on top. Honeycomb is by one of the Honeycomb is by Charity Majors. She's recognizing this community quite well. Then we have net data, we have SolarWinds and all that. Okay. Okay. Any other questions, guys? Okay. So
Shlok,
we are just gonna conclude. Okay. Yeah.
hello. Yeah, I guess I can
Yes,
see
please
many
go
questions on Slido. You can take
ahead. Okay.
questions from there as well. Yeah.
Okay. Okay. So I'll start from the top. Okay. As you mentioned, it's popular industries and helps to manage infrastructure. So should we learn and implement DevOps in our team projects too? Yes, there's no stopping you in doing that. You should. Ideally, as I mentioned, DevOps is a culture, right? So DevOps is something that a developer should know about before he goes and start writing code. You cannot just go ahead and write your Python code and write your application at this point of time. No, you need to be aware about DevOps practices before you go and dive into the industry. That's what my personal opinion is. People don't end up doing that, but this is what you would be if it, and life would be a lot easier for you if you do that. So you should go ahead and implement DevOps in your personal project. If you make an application, if you make a personal project like a simple calculator, um, containerize it. Okay, add it in Docker, right? Try to get a mini cube and deploy it in Kubernetes or things like such. Okay, that's gonna be nice. What role does Docker play in DevOps? I kind of mentioned it before. Do you want me to go through it again? The person who asked it. No. If someone's gonna say yes, I'm gonna answer it. Someone not. Let's skip it. Okay, let's skip it. Will you please explain the basis of DevOps which touches operations and development? Not on development side. Mm, not on development side. Then this wouldn't be DevOps. This would be just ops, right? Um, so essentially any practice that uh, is DevOps is mostly on development side. One thing, so if you just look at operations per se, let's decide. I can give you an example of incident management, right? Maintaining on-call shifts. So on-call is key. Someone has to be. So if like you're ordering something from Zomato at 2 a.m. in the night and Zomato goes down, there should be a person responsible for it, right? There should be a person who has to bring up the servers, even if it's 2 a.m. at night. Zomato has to fix the problem, even if its developers are sleeping. That's what on-call rotation is, right? So one developer is has to be on call. It has to be the first point of contact, but it cannot be the same person every day the whole year, right? You have to rotate it. So that's this on-call rotation, handling those rotations and all the ops stuff that's not related to development in DevOps. I hope I answered your question. If it's not, please speak up. Can industry survive without making use of DevOps? Yes, it can survive, but when it comes to the competitive edge, it's going to lose that, in my perspective. In my personal opinion, I don't think it can survive for a very long time, because the community is going to get far ahead of you. They're going to get ahead of you because they can do it things a lot faster pace than you can. You'll deploy a feature by the end of this week. They're going to do it in like minutes. So yeah. Okay, one question is what is Kubernetes? I answered that. If it's still not clear, please let me know. Just drop in. Ishita, can you just give me a rough idea from how much time we have?
I guess we have 10-15 minutes now.
Okay. Okay. Okay, let's start from bottom. What do you need to study in college to be really good DevOps engineer? Get the basics right. Okay, so I have a couple of books here. Okay, first is this. It's Site Reliability Engineer by O'Reilly. And the second one is this. It's Unix and Systems Administration Handbook. Right? Read these two. If you need a very short answer to what you should do, read these. Um, these are going to be very helpful. So just what I mean by that is just get your basics straight, man. You should know about what we do and why we do, rather than just diving into how you use a tool. So yeah. Since DevOps engineers are very less as compared to developers in a project, does workload increase? I want to answer that question saying every engineer is a DevOps engineer. DevOps is again a culture, right? And you cannot have DevOps engineers as separately, but industries tend to do that again. It varies from company to company. So if you have DevOps engineer country, yes, the workload increases, but the way to reduce it is that's the job of a DevOps engineer, right? To actually go ahead and have automated systems in place that can work on scale so that many people can use it. That's the work of a DevOps engineer. So you go ahead and automate system, you build systems for them to use so that you can decrease the manual effort made by you, right? That's what DevOps is. Okay. Please put book names in chat. That's a very good question. I'll do that. Just a minute, I'll do that. How do I get recognition in DevOps? Do I need a certificate? There are a lot of certifications out there. So there are a lot of good certifications. Uh, getting if you look at Kubernetes certification, it's an exam that will cost you 20,000 rupees. But there are certifications. You can go ahead and so for a particular cloud, you have AWS certifications. There are different levels of AWS certifications. You have GCP certifications. For Microsoft Azure, you'll have certifications. You're gonna have different courses, different certifications, but essentially they're gonna do the same thing. I mean, so having a Kubernetes certification is pretty great, right? But I can't say the same for having an AWS certification. GCP certification is again, it's pretty good, but I can't say the same for different certifications out there like Udemy, Coursera, and all that. Because essentially, what they'll do is they'll teach you the basics of DevOps and give you a certificate. You don't need a certificate. I don't have any certificate for DevOps. I looked at a lot of online sources. I've read a lot since I graduated about DevOps and all that, but I've never actually read it for a certificate. So you don't need a certificate to tell you you're good at it. You have a engineering degree. Look how you're good at engineering. So you don't need a certificate to tell you how good at you or something. Okay, so are companies willing to hire DevOps freshers or DevOps engineer? Okay, let's take this question after I conclude my slide. Okay, let's take questions after I conclude it. Just a couple of slides left, so I'm gonna conclude my talk, then I'll take the rest of the questions. Okay. Yeah. Okay. So essentially, we did not cover the skills required for DevOps. We're gonna do that. Okay, to just conclude everything, we know bad code is slow, right? It's as slow as a snail. It's it's essentially slow. You can have DevOps. Now, I explained so much about DevOps, so essentially we can actually go ahead and improve that with DevOps, right? It's we can have as many fancy roads, and we can do anything for bad code, but we cannot increase the speed of bad code just by using DevOps tools. We cannot do that. We need to have those DevOps practices in place. So even though I gave you introduction about all the DevOps tools, uh, just keep in mind I didn't give you instruction about one of the tools per se. I tried to give an introduction about the processes per se. So essentially, if your code is bad, none of the process is going to save you, man. You have to optimize your code. You should know how to write code, right? So again, if your code is bad, no DevOps practices can help you better. Okay, now this question, right? I've said so many things about DevOps in like past 1 hour or so. So like, what are the skills required to practice DevOps then? Right, I've covered almost everything. What do you think are the skills required to practice DevOps? Anyone? Anyone wants to answer that question? Come on, anything. Speak up. Just say something and meet us over here. People have slept already or what?
The
Okay.
major one is problem solving.
Yes, that's a major one.
Uh, Like
Nice.
anyone can learn tools. Like
Yeah,
how do you
exactly,
know
exactly.
what tool to use?
Thank you, man. This is the message I wanted to. This is the message I wanted to convey through this, and you got it. Thank you. Yeah. Okay. So yes, these are the skills required that I've mentioned today, right? I've mentioned soft skills, I've mentioned technical skills, I've mentioned that you should know software development as well. I've mentioned you should know operating system, containerization, you should know how to write documentation, you should know product management, troubleshooting, you should know about security. I forgot to mention security, you should know about that too. And there's something known as DevSecOps. So DevOps should be aware if the application is secure or not. It's so much to do, right? It's so much to do. So essentially, DevOps is a journey. There are a lot of so skills required are a lot, but it's not what every organization looks for in a DevOps engineer. As I said, key people have different expectations. You need to broaden your horizons. You might not have to need to go into depth as a graduate. Most of you are college as of now. So as a person who's going to graduate in the next year, next couple of years, or who has recently graduated, who wants to shift from software development to DevOps per se, there are you should start with broadening your horizons first, right? These are soft skills, problem solving, communication. These are soft skills. You can go ahead and help. I cannot help you with these. Yeah, you have to help yourself with these. You have to get into a mindset where you go ahead and give different talks. You have an extrovert type of personality where you can evangelize different practices in your company itself, right? So if you go ahead and implement CI/CD, your developers don't know how to use CI/CD. It makes no sense to do that. So you have to evangelize that problem solving skills in your organization. So you have to get your soft skills in order. Then rest of the systems, you have to have a broad uh, understanding of it. You should know the width of it, but it's not necessarily to know depth about everything. You can go deep about databases and just scratch the service about the rest. It's fine. Right? This is not a single person who does all that job. It's not a single DevOps engineer who is be expected to solve all these problems. No, he's not. Um, Unless you're a lot experienced. This is not how it works. Okay, so go if you're good with Docker, you're good with containerization, you have one of the skills, and you know the basics of operating system, how it works. You know the basics of software development. You have some projects to show for yourself. You know how to write unit test, integration test. You know basics of testing. You know basics of monitoring. I just covered monitoring for you, man. This is what they're gonna ask as a graduate about monitoring, right? If so that's it. That's how you can become DevOps. I know it's a little too much for around this slide. There's just too many skills out there, but essentially you can sum it up. It's a journey, right? Once you start, it's gonna become easier. It's gonna become very very interesting. Okay, so that's it. Um, Thank you, folks. This is my Twitter. If you have any questions, anything, please if you have any feedback or anything, any negative comment or anything, just reach out to me. Just let me know, okay? Any negativity is gonna help me improve. So just just do that. And now I'm gonna answer questions, slider questions. Okay. Okay, let's answer our slider questions. What do you need to study in college to be a really good DevOps engineer? As I mentioned, um, those books about Linux and site reliability engineering. The book about the book about SRE, it is actually very good in terms of to get that mindset, right? It's going to give you that DevOps mindset about what you should do, DevOps practices, about what site reliability engineer is, what to monitor, why to monitor. It also go into CPU utilization and things like that. So it'll cover the basics for you very well and will help you get into that mindset. When I meant CPU utilization, I meant it's gonna cover what you're actually monitoring and elaborate about it, explain what it actually is rather than just a percentage, right? So yeah, do that. Above LinkedIn link is correct. Yes, I hope so. Okay, next questions. Are companies willing to hire freshers as DevOps engineer? Yes, companies are willing to hire freshers as DevOps engineers. When it comes to startups, yes. When it comes to MNCs like LinkedIn, Google, and all that, they also hire DevOps engineers. I know people in LinkedIn as SRE1, so they hire as SRE1. Mostly LinkedIn has site reliability engineering. Same with Google. That's what to say. Amazon has DevOps engineers. So, they hire DevOps engineer one. They are willing to hire fresh graduates. Uh, and same goes to different startups. They hire fresh graduates, and to get selected there, you need to get your basics straight. You need to get why we need DevOps, the things that I talked about, plus uh, you have to get in depth with some of the things that I talked about. I just covered the breadth of it all. Some of the things I talked about, you have to go and read about in depth, just Docker, Kubernetes, and all that. Okay. If you have any doubt, you can always reach out to me. Okay.
I just have one general question. Like it will also help many freshers out there. Can I ask?
Yeah, Sahil, sure.
Okay, so I checked out your profile. Like you are also a Google Summer of Code student, and
Yeah.
in your experience, did that help? Because in my experience, whenever I mention that I'm a GSOC student, they are like, "You're not fit for the DevOps role. You should apply for the SDE role." Also, when I
Okay.
applied for startups, they are like, "Okay, you have cleared the interview, but you don't have the required experience and you are fresher." How would I get that experience if you don't hire me? So, how would you like to describe this? Like, what can I do to get that
Hmm.
experience, which I cannot get because I am not hireable according to them?
If you look at this problem now, this is you don't necessarily have to go to those companies that hire for experience. Yes, I know out there ki everyone is looking for experienced developers, but not everyone is. Okay, for in my opinion, as you mentioned, I'm also a GSOC student. I did GSOC in my second year and my third year. Uh, when I went to an organization, I started as a software developer intern there, right? And I wanted to switch to DevOps. I went ahead and I did as much research and as studied as much as I can about for months about what DevOps is, about different practices. Read as many books as I can, and then I went ahead and then talked to my CTO. Hey, I want to make a switch to DevOps. That this book's SIE Site Reliability Engineering by O'Reilly is actually a suggestion by my CTO at Clarisights, Ashupajali. So he says to read, go through this. It gives you the right mindset to be DevOps. That being said, not all organizations look for experience. If they are looking for experience, then probably not the right candidate. Try to go for initially for maybe startups. So organizations have a lot of money. To be honest, MNCs have a lot of money, right? They can hire people who are a lot more experienced than you. The same the same doesn't hold true for startups. They don't have that much of money in hand. I'm not talking about startups like Ola, Razorpay, and all that out there. I'm talking about startups that are currently in like seed stage or pre-seed stage. So they don't have that much money in hand. They want to hire someone who can do their task, who is good at it, who they can actually share their vision with, rather than someone with good technical skills. So look for startups to start with DevOps engineering if you are having a tough time cracking MNCs. Otherwise, I can connect you with few people who are currently in LinkedIn who are fresh graduates. They can probably help you out with that question.
One more like question.
Yeah.
Let's say you have a scenario where you are being offered, let's say, as a cloud engineer at a slightly lower pay in a startup or a mid-range company, or as a Java developer at a product-based company at a higher pay. So, what would you pick if your future aspirations are being a DevOps engineer?
Uh, okay. So you mentioned cloud engineer at a lower
Yeah.
pay and a Java developer at a higher pay,
Yes.
right? That's the gist of it all. Uh,
Yeah.
gist of it, right?
What I
Pay
meant
does.
to say is, let's say I pick Java developer, and in
Mhm.
future I want to switch, and now I know like the companies are like, you have worked on this, So again, work on this. Like it's a rabbit hole.
Yeah, it's okay. I agree. Okay. Uh, you to as a DevOps engineer, I'll suggest you to go with the cloud engineering with the lower pay. Essentially, as your compensation as a fresh graduate doesn't matter if you passed out. This is according to my personal opinion. Again, if you completed 4 years of undergraduation and you graduated with 4 LPA and the person next to you has got 15 LPA and you feeling bad about it, it doesn't matter. 1 year you might be with 14 and this guy will be the same, right? So your compensation doesn't matter as long as it aligns with your interest. When you switch, people are willing to pay you a huge but load of hike. So the compensation as a graduate, it should not matter as much. Some people have a contradicting opinion ki it should matter because when you get hired by a new organization, they go by this 30% margin of paying you 30% more than you previously were paid before. But if you're good with your skill set, nobody cares about where you're from, about what you have done, about anything. Nobody cares. About your college degree or anything. Just if you can solve the problem, then why not, right? So yeah, I think compensation doesn't matter. As a graduate, you should go ahead and do the cloud engineering role at a startup. That's probably going to be a good idea. What was the other part of the question again? Can you repeat that? There was another part.
Like how do you escape that rabbit hole? How do you convince? Like, I try to
Uh-huh.
convince the hiring managers, like, I am the sole person who is responsible for maintaining my GSOC projects. It's running over the all over the European universities. Then why, like, you don't have experience? You have the SDE experience. So, how do you convince them
Uh-huh.
for a switch, basically?
Okay. Sahil, okay, if you go ahead and say that to someone, have you worked with DevOps before? The
Uh,
problem is, okay, yeah.
like,
Have you
not
worked with DevOps, like
not
in
in
your
a
personal
way.
projects? Do you have any personal projects?
What I
So
did,
what?
I had personal projects. For the interviews, I migrated them their deployment to Kubernetes to show them like now I have experience. Now please hire me. That is
Okay.
what I did.
Uh, Ideally, if this should have worked, according to my opinion, they might not be right. Okay, every company has different opinion. If you're looking at MNCs, uh, they have like strict fast rules key the person should be this main technical proficient as such. Not all companies do that. They look for how much can this person learn and grow in the according to what he knew. If as a software developer you went ahead and moved their workload to Kubernetes as an assignment, I'll consider that an achievement, right? If I was the person, I would seriously consider having a very serious interview uh, and hiring a candidate who can do that. But it depends upon company to company. So you just had been you have you might have a bad experience in interviewing for a couple of companies, but it's not the same way around. It's not the same way around, bro.
I'm hoping for the same.
Yeah. Tane mentioned something in the chat that might be helpful as well. Contributing to open source DevOps tools help in this case. Yeah, it would. It would actually have an impact of. So if I'm a contributor to Elastic and I go ahead and apply as DevOps position, it just knows ki, hey, I know Elastic in and out. I know this, but it's not in and out, obviously. This particular part of Elastic code in and out. I know about index lifecycle policies very well because I worked on it, right? Who else can know it better than you do? So that's yes, it's definitely helpful. Thank you, Tane.
Yes, Shlok, I guess we are running out of time now. So I think all the queries have been acknowledged properly. And if you guys still have any doubts, you can connect with Shlok on LinkedIn and ping him if you have any doubts left. The link is in the message window, I guess. Now I think it's time to wrap up the session. Thanks, Shlok. We are very thankful that you managed to pull out some time from your busy schedule. I'm sure that many of the minds present over here got benefited from this session.